Hello, and welcome to day 2 of Python. Okay, so in the beginning of the day, we have this quiz, and I'll go over the question about the quiz. So the first question is, what is the truth table of this OR clause? So for example, if you had x equal to false and y equal to false, what would x or y result in? The next question is, what is the result of this expression? True or false and false? And then the third question is, we want a function that returns true if a number is positive, otherwise return false. And the fourth question is, we want a function that, given 3 inputs, it counts the numbers that it sums up all the numbers that are even. Okay, if you haven't had a chance, pause the video and try each of these problems, and then unpause. Okay, so for this answer, this would be false, because for OR to be, the only way for OR to be true is that at least one of the inputs has to be true. Therefore, this next one is true because y is true. This next one is true because x is true, and this next one is true is because they're both true. Okay, and then this one is a bit tricky because if you execute this from left to right, you actually get, if you execute this statement first, which is true or false, that would be true. And then if you execute this statement next, this would actually be false, because true and false is equal to false. But the way that you should look at this is that you should always remember that there's an order of operations with ands and trues, and ands have precedence over ors. So the way you want to execute this is that you'll execute the second part first. So this becomes true or false, and then this true or false becomes true. Okay, so this next function, we just need to use a if clause and return true if the number is greater than 0. It's simple as that. So if the number is greater than 0, return true, and then we should also return false in any other scenario. So this is a pretty good solution, but we can actually simplify this so that we just return, rather than doing an if clause and then returning true if the if clause is successful, we can just return the condition within the if clause like this. Okay, and for this next question, there's multiple ways of doing this. One way of doing it is that you would check if all the numbers are even, then sum them all up together, and then you would check if 2 of the numbers are even and then sum those up, and otherwise you check if each individual is even, then you just return that individual number. And if you were to go down this route, you would end up with about 6 if-else statements, or just if statements. A different way of doing this is we want to have a variable to keep track of our sum. So call it sum. And then we check if the first number is even, and if it is, we add that first number, and then we want to do the same thing for x and y and z. Great. And that's basically it. That's the quiz. Now on to today's material. So before we learned about if statements, And what I'm going to introduce is a if-else statement. So imagine we have a function that greets someone based on the hour. So if it's less than 18 hours, which is same as less than 6 p.m., we want to say have a good day. Otherwise, if it's greater than or equal to 6 p.m., we want to say have a good night. One way of doing this is we have two if statements, one checking less than, one checking greater than or equal to. But since these two if statements are what we say mutually exclusive, we can just use an if-else statement like this. So in here, we check if the first section is expression is true. If so, we execute it, and then this will jump directly to line 8 after this is complete. It will not jump to line 6 because this is in a if-else section. So in an if-else section, it always ensures that one of the if statements, either the if statements are executed or the else statement is executed, but it will never execute multiple sections. And after it completes executing the correct section, it will jump out of the entire if-else grouping to line 8. Okay. So yeah, that's basically it. So the syntax of the if-else looks something like this. As the code executes, we jump to line 1, and then as we go to line 2, we check if the condition 1 is true. If it is, we execute statements on line 3, and then and additionally any other statements in this group, then we would jump directly to line 6, which is the end of the if-else grouping. We don't even consider the lines 4 and 5. And now let's imagine that the condition was false. If the condition was false, then we jump directly to the else group and execute those statements. And when those statements are done, we just jump to the next line, which is outside the if-else group, to line 6. Okay, yeah, that's basically it. Now we're gonna jump into the next topic, which is the if, else, and else if. And in here, we use this group of statements if we want to have some complex logic that depends on multiple conditions. And one thing to keep in mind is that when you have this if, else if, else if, else if, else, only one of these statement groups will be executed. And the statement group that would be executed would be based on the first condition that succeeds. So if condition 2 is true, we would execute this group of statements. Then we'll jump directly to line 12, which is outside this entire if-else block. Another thing to keep in mind is that you can have as many else ifs as you want. So in Python, else if is shorthand by elif. So you can have as many as you want, or you can not have any, which is the same as the previous example. And another thing is that else does not have a condition attached to it because it will cover all other conditions. And you do not even need an else in your I guess if, else, else if grouping. But if you do have an else, it has to be the last statement or last section. Okay. So let's see this in play. Okay, so let's look at this example. In this example, we are first checking if the hour is less than 12 o'clock. If so, it's still morning, so we set greeting to good morning. If the hour is exactly 12, we say it's good noon. If the hour is less than 6 p.m., we say good afternoon. Otherwise, we say good evening. So if we pass in a certain hour, for example, let's pass in hour 10. If hour 10 is passed in, we see if 10 is less than 12, that's true. So we execute this line on number 3. Then we jump right out of the if-else groups, and we jump directly to line 10. And at line 11, we return the greeting. Let's do another example where the hour is 13. So if the hour is 13, then these two conditions are not met, but this third condition is met. So we execute line 7, and then we setting the greeting to good afternoon, and then we return greeting right after. And then a final example where the hour is 20. None of this condition is not met. This condition is not met. Same here. So it has to execute the else condition and then jump out of the loop, or not the loop, but the if-else statements, and then return the greeting, good afternoon. Okay, so this is, you should ignore this, pretend you did not see that. So this is a exercise where we want to do something similar, but we want to see if we want to have a greeting that says hello boy if the person is less than 13 years old, and we want to say hello teenager if they're a teenager, and we want to say hello mister if they are younger than 35 but older than a teenager, and if they're older than 35, we want to say hello sir. And just pause the video and try doing this yourself. Okay, so you're back. What we can do is we can first check if someone is a pre-teenager. So we check age is less than 13. Then we can say the addressing word is boy. And now then we can do an else if to see if they are a teenager. So if someone's a teenager, if their age is greater than or equal to 13, and age is less than or equal to 19. And hello teenager. But one thing to keep in mind is that we don't need this section where we check that the age is greater than 13. It's already implied by the previous if statement. If this if statement were to be true, then we would have gone here already. So the age must be already greater than 13, greater than or equal to 13. So we can just take that out. Okay, and then the next if statement is we check if someone's less than or equal to 35, and then we say that the addressing word is Mr. Note that I didn't have to check if the person was a post-teenager. The reason I know that they're a post-teenager is because if they weren't a post-teenager, they must have been a teenager or a boy. So we don't have to make that check. We just have to make sure that they're less than 35. And finally, we can just have the last scenario be an else statement. And that will just be hello sir. And yep, that's basically it. That's the answer to this question. on to the next sections. So in day one we talked about a lot of different data types. We have ints and floats, which both represent numbers, and we also have booleans, which represents true and false. And now we're gonna introduce you a class of functions called collections. And collections allow us to have a variable number of items in a specific object. So one collection is a string, which is just a list of characters used to represent text. And to construct a string, we used single quotes. But we can also use double quotes if there's a single quote within the string. But if the string has single quotes and double quotes, we can use triple quotes to escape both of them. Additionally, we don't have to we can just use a backslash whenever we encounter a double quote or a single quote. Okay, let me run through some examples. So we can set a string using a single quote. We can set a string using a double quote. And then we can see that these two strings are the same. If a string has a single quote in it, like for example, it's my birthday, and we try to wrap this within a single quote, we'll get an error. The reason is that Python will think that this is a string and then the rest of this is garbage. So we have to wrap it within double quotes. And there you go. Or you can wrap it within single quotes and just escape that other letter. So if we check these two are the same, yes, they are the same. And then finally, if we have a string that says something like George says it's my birthday, then we can wrap this entire thing in triple quotes. Oops, I need one more quote. Let me try that again. Triple quotes. Great. So when we print this out, we see what we expect. One more thing to know is that we cannot wrap this into triple quotes because the last letter of the string is a double quote. So we can't wrap this within. So we can't wrap the string within triple double quotes because the last letter here is already a double quote, and that will confuse the compiler. But we can just escape this last letter if we want, and we'll get the same result. Y equals X. Great. There are a couple things we can do on strings. We can get an index of a string. For example, index 1, that would return the second entry. The reason why it returns the second entry is in programming and in Python, we start counting with 0. So H would be 0, E would be 1, L would be 2, the other L would be 3, and the last one would be 4. We can also do negative indexing where we count backwards. So the last number would be -1, then it will be -2, -3, -4, -5. We can get the length of a string. We can convert a string to a lowercase number, or we can convert it to a lowercase. We can convert it to uppercase. We can concatenate two strings together to create another string. We can convert a let me do this. So we can convert a an object of a different data type to be a string. And then we can check if a substring exists within another string. So he exists in hello because it's the H and E is right there. So let me do some examples of some of these. So you have x equals hello. X, the first element is H, second element is 1, the last element is O, the second to last element is L. We can do an upper, and we get all capitalized hello. One thing to note is that when we look at x again, x has not changed. If we do want to change x, we have to reassign x to the result of calling upper, like that. And then, so we have this x right here. We can add it to, we can add it to a string that has a empty space and a world. So the result of this is hello world. It is important to know that when we add things together, it does not modify the original string. So you would have to set x to be this plus the new string. Okay. And what else? So we can convert a number to a string. We can convert a boolean into a string. We can convert a float into a string. We can also convert like another type of boolean into a string. So yeah, that's cool. You might be wondering why would we ever want to convert things into strings. The reason being is like if you have a string before, like 1, 2, 3, and try to add 4, this would actually throw an error. So you can only concatenate strings with each other. So that's one of the reasons you want to convert things into strings. And checking for existence. So we have the word hello. So we can check if E is in hello. Yes, it is. We can check if hello is in hello. The answer should be yes. Hello. And it is. Okay. Now for this next section, take a minute to give your guess on these questions, and pause the video and unpause it when you're ready. Okay, so you're back and ready to roll. So this first question, we want to get the index 2. Since we start with counting by 0, R is 0, A is 1, and C is 2. And in this example, we want to count the -2 index. So R is -1, A is -2. In this example, we want to see if me is in team, and it's not. Even though the letter M is in team and the letter E is in team, both of them are not together in the same. It's not a substring. Like it would have to be M is before E, right before E. And this next one is a bit tricky because it requires multiple levels of execution before actually getting to the result. So let me refresh this. So we have something that looks like this, and then we want to add the string to this expression. What does this expression evaluate to? We would have to evaluate the inner expression first. So that would look something like this. 1 is greater than true. That is 1 is greater than 3. That's true. That's false. And then we want to do a stir of false. That becomes false. And then when you add these together, it just looks like this. Great. So let's type it in the repo, see if that is the same. Yes, it's the same. Great. And this next one, I don't expect you guys to know the answer, but it will repeat hello 3 times. And this is just something specific to Python and how it interacts with numbers and strings. Usually, if you have 2 different data types, you won't be able to do certain operations. This is one of the many. This is one of the, I guess, only operations you can do with a number and a string. For example, if you have a string that says beep, try to add 5 to it, this will throw an error. But if you try to multiply 5, this will do beep 5 times. It's just something interesting. Probably not important to remember. Okay. Next, we're going to talk about lists. And we can create a list with an empty bracket. Or sorry, with a open bracket and a closed bracket. So this will create an empty list right here. But we can create a list with entries in it. So this list will have 3 elements. The first element is number 1. The second element is the letter A. And the third element is just an empty list. So you can have mixed types within this list, but all the different values are going to be separated by commas. Okay. So a couple operations that we can do on lists is that we can get the index of a list. Remember, we always count by 0, so index of 1 is 0, 1, which is A. Negative 1 is this last one, which is true. We can get the length of the list, which is 3. We can add an element to the end of the list. So if the list was 1, 2, 3, 4, and we add 5, we use the append function and we get a 5 there. If we can modify a specific index and change it to another value. So in this example, if my list is ABC, we modify the first index to be D. This becomes D, so when we print it out, it becomes ADC. We can remove the last element using a pop function, and when we call a pop function, that function will return the last element, and then afterwards it will modify the list to not have that last element anymore. So when we run this code, we get E because that's the last element, and we print it out. We get the list without the E. And another thing we can do is we can remove an element. We can remove a value from a list. So this has A, B, C, D, E. If we remove B, B no longer exists in the list. Another thing we can do is we can convert other data types into a list. So if we convert a string into a list, we just get the individual letters as entries to a list. Another thing we can do is we can check if a number or if a value exists within a list. 4 doesn't exist here, so that's false. And one more thing we can do is we can split a list by space, and that way we get the words from the list. Okay, in this next section, just try to guess what these would execute to, and then also play with the REPL tool to see what the actual result is. Okay, so you're back. The first one should be straightforward. 0, 1, 2, so that's C. And here we remove 1, so that's remove 1 is 2, 3, 4. And here, when we try to remove 1, it's actually throw an error because 1 does not exist in the list. And whenever an error occurs in your code, what happens is the whole program will stop. where, yeah, so you want to write code so that it doesn't have errors. Ideally. So here, this would find all the O's, and it will remove the O's, and then the words, the characters in between the O's become entries to a list. So this would look something like this. There was an O in between here before. There was an O here. There was an O here. Those are all gone, and they have been split. And this next one is a trick question, kind of, because you can see that 1 is here, 2 is here, but when you enter this into REPL, this is false. The reason for this is this expression is checking if the list 1, 2 is within this list. And it's not, because all the elements in this list are numbers. None of them are lists. So if we were talking about a different list where the first element was the list 1, 2, and the next one was 3 and 4, then this would be a true statement. Okay, this last section will cover dictionaries. And a dictionary allows us to hold a key to a value. You can think about this as an actual dictionary where you have a word and then it maps to the definition of that word. To create a dictionary, we use curly braces, so this will create an empty dictionary. But we can also create a dictionary with values in it. So the Adam would be the key, and the value would be 23. Eve would be another key, and the value is 21. It's important to know that for keys, they must be an immutable data type. And for this class, immutable data types will be strings, integers, and booleans. And values could be any data type that you want. It could be a number, it could be a boolean, it could be a list, it could be another dictionary, it could be anything that you want. So a couple things that you can do with a dictionary is that you can add a key value pair to the dictionary. So we're adding Kevin and setting it to 25 for this age by name, and we print out Kevin exists on this list. Another thing that we can do is that we can update a previous value from this list. So if Adam was 23 and Eve was 21, and we set age by name of Adam to be 24, when we print this out, the new value of Adam is 24. So another thing we can do is we can get a value from a key. So we want to see how old Adam is. We just pass in Adam, the string Adam, and then we get 23 back. If you call age by name with Adam, and Adam is not within this list, or sorry, within the dictionary, an error will be thrown. So you want to not do that. We can also remove an element by key by writing del space age by name, and then we pass Eve, or any key you want, and that key will be removed. The key value pair will be removed. We can test for existence, and in the existence test, it will test to see if the key exists within the dictionary. You can't check if the value exists in the dictionary because, similar to a dictionary, you can only search by the word, not the definition. You can get the length of the dictionary, so you can get the number of key value pairs, or another thing you can do is you can get all the keys of the dictionary, which in this case is Adam and Eve, or you can get the values of the dictionary, which is 23 and 21. Okay, given this, try to solve all of these exercises and come back in a minute. Okay, so in this first example, we create the dictionary D. We create a dictionary, assign it to a variable D, and then here we set the key 1 to map to Adam. This is a bit confusing, but this is especially confusing because this is a very abstract dictionary that the keys could be a string or a number. Usually the keys are one data type and the values are one data type, but there's nothing preventing you from mixing up data types. So what ends up happening here is that the keys to this dictionary will be Adam and 1. So Adam will map to 1 and 1 will map to Adam. Looks looking like this. Whoops. This is what it looked like before, and now this will map to Adam, and this will look like so. Adam maps to 1 and 1 maps to Adam, but we can make 1 maps to Eve, and this will update what 1 maps to. So this is a bit confusing because a value is also a key, but one thing to keep in mind is that they're independent of each other. So this 1 doesn't have to be the same as this 1. We can set Adam to be 2, and oops, and then yeah, it'll just update that value. And this next example, we see if 1 is in this dictionary, it is a value of the dictionary, but it's not a key of the dictionary, so this will be false. In this next example, we want to get the value of Eve. This will throw an error, and because Eve is not in this dictionary. Similar here, this will also throw an error because we tried to remove Eve from this dictionary. Yeah. In this next part, we want to go over ranges. So range is a data type that represents a range of numbers, and we can convert that into a list by using the list conversion function. So if we have a single argument and we pass in 5, it will give you all the numbers between 0 up to 5, but not including 5. So one thing to remember is the last number, the ending number, is not inclusive. For example, if we have 2 arguments, 3 and 10, this would mean we would start with 3 and we go up to 10, but 10 is not inclusive, so it will do 3, 4, 5, 6, 7, 8, 9 without 10. Another example is we can have 3 arguments, and the last argument is the step function, or not step function, but step number. So we start with 3, we step by 2 up to 10. So 3, 5, 7, 9, and that's it. And the step function can also be negative, so we can go from 10 to 3. So 10, 9, 8. Oh, sorry, 10, 9, 8, 7, 6, 5, 4, without the negative 1. Okay, and now take your time to see what this would result in and come back in a bit. Okay, so you're back. This first one would just be the range between 0 and 6, which is 0, 1, 2, 3, 4, 5. And this next one is the same thing and very identical. And this next one, this would actually return an empty list because this starting position is actually less than the latter number. So this would be an empty list. And this next one would be 0, 3, and that's it. It does not include 6 because 6 is not. It's a ending number, so it's not inclusive. Okay, great. So in this last section for today, we're gonna deal with for loops. And you can run for loops on a collection, and what it will do is for every element of that collection, we will execute a entire group of statements. So for example, we can execute this we can execute a for loop like this. And the way that for loop works is that there's a for statement, and then there's a variable name. We can have this to be any variable name, and whatever variable name this takes on, it will have the values of the collection one at a time in a certain order. So next we have an in statement, and then the actual thing that we can iterate upon. Then we have a body of statements. So here we have for x in 1, 2, 3, 1, 2, 3. We print out x. So first x will be x will have the first value, and we'll execute this body with x equal to 1. Then we execute the body with x equals 2. We execute the body with x equals 3. So we get 1, 2, 3, 4, or 1, 2, 3. We can do this with strings, and we get hello. We can do this with range. We get 0, 1, 2, 3, 4. We can do this for a dictionary. When we execute a for loop on a dictionary, we'll loop over the keys of the dictionary. So in this case, it'll be Bob and Alice. But one thing to note is that a dictionary is actually not sorted. So even though Alice comes before Bob, when we loop over, we might be able to print Bob before Alice. Okay, so let's look over some examples. This will loop over the range between 5 and 10. So similar to the example above, this will print out 5, 6, 7, 8, 9. Another example is that we loop over a dictionary. So we get the keys of the dictionary, and we can actually get the value of the dictionary by indexing the dictionary with key. So we have this new value, and this next line, what it's doing is it's setting that value to be value plus 1. So it's incrementing every value in this dictionary by 1. In this next example, we are looping over a word. So we're looping over to get all the characters of the word, and we're checking if the character is a vowel. If it is, we increment a counter variable. So this will count the values in this word. And this next example is a bit complicated, but it will return you a max number given a list. The way this works is that you have a variable that keeps track of the max value so far. And initially we set it to none. So none is a special type that you can assign to any variable to indicate that there's no value so far. So in this loop, what we do is for each number that we come across, we see if the max so far is none. If the max so far is none, we can set the max so far to just be the current number. But otherwise, we check if the max so far is less than the number, or another way of saying this is that the number is greater than max so far. We can update the max so far number to be this current number. And at the end of all of these numbers, we get out of the for loop, and then we return the max so far. Okay, so there are a couple exercises that I want you guys to practice on your own. So the first one is we have a list of numbers and we want to return the count of the even numbers on that list. The next, we have a dictionary that has people's names and that map to their ages, and we want to return the list of names that are over 21. And in the last one, we want to see if there are duplicates within a list. Okay, let's get at it. So for this one, we just need to loop over all the numbers, and then if the number is even, then we want to update this count variable that we have up here, and then at the very end we want to just return the count. Simple. And in here we want to loop over all the keys of this dictionary, and the keys are names, so we can just call the variable name in age by name. So we can get the age by using the original objects like this. And now if the age is over 21 or over, we can add the name to this result and return the result. Okay, so this next one, we have a double for loop, and we have the variable I and j. The reason why we're using the variable I and j is because we're looping over the range of the list. And the one reason why we're looping over the range of the list is that we want to find duplicates, but we want to make sure that we're not counting the same number as a duplicate. So we're doing a double for loop to get pairs of numbers, but we want to make sure that I and j are not the same. So one thing we can do is we can do so we have num I would be equal to the list of things at the I index, num j is the list of things in the j index, and then if these two numbers are the same, then we want to return true, and at the very end we want to return false if all the two pairs are not matching. But one thing we want to keep in mind is that we want to make sure that I is not the same as j. If I is the same as j, then we're actually looking at the same index, and of course the same index will have the same number, but that does not count. Okay, that's basically it, and yeah, that's basically it for today. There's some homework here. So this first homework is called FizzBuzz, where we have a function that takes in a list of numbers, and then it will print out the number by default. But if a number is divisible by 3, it'll print out 3. If it is divisible by 5, it'll print out buzz. If it's divisible by 3 and 5, it'll print out FizzBuzz. And in this next function, write a function that tests if there exists two numbers that sum up to 0 in a list. So in this, for example, there are no two numbers in this list that returns 0, so this is false. And this is the next example, 1 and -1 sum up together to become true. Okay, and in this third question, it's called missing number. So we have a number between 1 and 5, and we want to return the lowest missing number, or actually any missing number. So in here we're missing 4, so because 1, 2, 3, no 4. In this next one we're missing 2, This next one we're missing 5. Yeah, that's basically it.